Okay, welcome back. So we're going to look at the second half of your note sheet, and it says measures of variability. So yesterday we talked about measures of variability. The measures of center is something we've been kind of already working on. But measures of variability are also called measures of spread. These measures describe how spread out the numbers are in a data set. So the closer the numbers are together, that means your data is more similar. And the more spread out they are, there's more variance or they're more varied. Uh, so when we look at the range tells us variability. It's a measure of variability that describes the spread in the data set. So to find the range, you subtract the least from the greatest. So I always take max minus min. So pause the video, find the range of Miss Johnson's sleep study. Okay, the range is 4. So our data only varies from 4 hours in this particular set of data. So interquartile range, I talked about a little bit the other day, and then we looked at it again yesterday. It's a measure of variability that describes how spread out the numbers in the center of a data set are. So to find the interquartile range, you subtract the first or lower quartile, we say Q1, from the third or upper quartile, Q3. So Q3 minus Q1 gives us the IQR of the data. So you have to pause this video. You have to find Q3 and Q1 and then subtract and then come back and check your answer. The interquartile range is 2. So that middle 50% of our data is only spread out by 2 hours. Yesterday, we did a lot with mean absolute deviation. Mean absolute deviation is a measure of variability that describes the average distance each number is in the data from the mean. So to find the mean absolute deviation, we have to take each of the numbers of our data and subtract that from our mean. Once we do that, we get the absolute value of those differences, we add them together, and divide by the number of pieces of data. So for this particular piece of data, our mean is 7. And when our mean is 7, we take each of these numbers and subtract them from 7. And we want the absolute value of that. So I am going to just work right here on my sheet. And if I have 7 minus 6, that's 1. 7 minus 7 is 0. And it's important to include the 0 because it is part of your data set. 7 minus 8 is negative 1, but I'm talking absolute value here. 7 minus 5 is 2. 7 minus 6 is 1. 7 minus 7 is 0. 7 minus 8 is 1. 7 minus 8 is 1. 7 minus 9 is 2. 7 minus 8 is 1. 7 minus 5 is 2. I'm going to go back. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pieces of data. Do I have 11 differences in absolute value form? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I'm going to add these numbers. Okay, so when I added up the absolute value of the difference between each piece of data and my mean, I got 12. That's my total right here. I have 11 pieces of data. So to find the mean absolute deviation, I do 12 divided by 11, and that gives me 1 and 900ths, but the 9's repeating, or the 09's repeating. So it's 1.09 repeating. That's what that line over it is. That means that my data only varies by a little over 1, which means my data is pretty concentrated. So thank you for watching, and go ahead and get to the other practice pieces.